Today we are starting a new unit on applications of trigonometry. Today we're going to focus on right triangle trigonometry. By the end of this video, you should be able to solve right triangles using SOHCAHTOA, and you should be able to understand angles of elevation and depression. First, to solve a triangle needs to find all 6 measures, the 3 sides and the 3 angles. A couple of notes. First, we are going to round our final answer to 3 decimal places. Second, never round in the middle of your work. This will produce round-off error, meaning that each time you round a number, you get a tiny bit farther from the real answer. So we will only round our final answers. So, a little reminder from geometry. If you have a right triangle, meaning that one of the angles is a right angle, I'm going to pick one of the vertices and label this A. So if I am standing at angle A, the side across the triangle is our opposite side. The side across from the right angle is our hypotenuse. And the third side, which should be next to angle A, is called the adjacent side. Now, hopefully you remember SOHCAHTOA from geometry. This helps us remember the 3 trig functions: sine, cosine, and tangent. So if I want to find sine of angle A, that will be opposite over hypotenuse. And we can remember that by SO, sine, opposite, hypotenuse. If I want to find cosine of angle A, that is going to be the adjacent side over the hypotenuse. We can remember this by cosine, adjacent, hypotenuse. If we want to find the tangent of angle A, that will be opposite over adjacent. We can remember this with TOA. Tangent is opposite over adjacent. Let's take a look at this first example. We want to solve this triangle, which means we need to find the missing angles and the missing sides. When you are trying to solve a triangle, you always want to use the information that you are given to find the other angles and sides. That way you don't have any round-off error. Since we are given angle A, we know that that is 49 degrees. I'm going to label my triangle as if I am standing at angle A. So this side is my hypotenuse, this side is the opposite, and this side is the adjacent side. to help with our calculations in a few minutes, I'm also going to label the side opposite angle A as side A, the side opposite angle B as side B, and the side opposite angle C as side lowercase c. Now, we know that we have a right angle. We know that one of our angles is 49 degrees. We need to find the third angle, which is angle B. We know that the sum of the angles in a triangle is 180 degrees. Since we have a right triangle, one of the angles is 90 degrees. The sum of the other two angles, which in this case are angle A and angle B, is 90 degrees. So we know that the measure of angle B is 90 degrees minus 49 degrees, which is 41 degrees. It is important that you put the degree symbol on your answer because we will, in the next unit, learn about another measurement for angles. Now, we know that side A is 7. We need to find sides B and C. It doesn't matter which one you find first, but I'm going to go ahead and find side C. When you are trying to find a side, always use the side that you are given, which in this case is the opposite side, and then the side that you want to find. So if I'm trying to find side C, that is the hypotenuse. So I want to think about SOHCAHTOA. Which one, sine, cosine, or tangent, uses opposite and hypotenuse? Well, that's sine. So I can write an equation, sine of angle A, which is 49 degrees, equals opposite, which is 7, over hypotenuse, which is side C. So now I just need to solve this. If I multiply both sides by C and then divide by sine of 49 degrees, I get that C is 7 over sine of 49 degrees. Now is the appropriate time to use your calculator. Now, first you need to make sure that your calculator is in degree mode. So click Mode, go down to radian, over to degree, and hit Enter. Now, we need to do 7 divided by sine of 49 degrees. And if we round this to 3 decimal places, we get 9.275. So that is the length of side C. Now, let's find side B. So I was given the opposite side. I want to find the adjacent side. So tangent is opposite over adjacent. So I'm going to write out an equation. Tangent of 49 degrees equals opposite, which is 7, over adjacent, which is B. If I solve for B, I get B equals 7 divided by tangent of 49 degrees. And then if I plug that in my calculator, and round to 3 decimal places, I get 6.085. Now I have found all angles and sides, so I have solved this triangle. Next, we have another triangle, and again, we want to find all of the sides and angles. But this time, we are given 2 sides. So I'm going to label these as side C, because this is opposite angle C, side A, and side B. Since I am given 2 sides, to find the third side, I want to use Pythagorean theorem. So, Pythagorean theorem says that a squared plus b squared equals c squared, where c is the hypotenuse. So I have a squared plus 8 squared equals 14 squared. So I get a squared plus 64 equals 196. A squared is 132. Then you need to take the square root of both sides. 132 is not a perfect square, but 132 is 4 times 33. So I can simplify this to 2 square root of 33. Or if a problem asks for the exact answer, you can type that in the calculator and round to 3 decimal places. So 2 square root of 33. So 2 square root of 33 gives me 11.489. Depends on what the problem is asking for, whether you should give the exact answer, which is 2 square root of 33, or the rounded answer, which is 11.489. Now we need to find the two angles. It doesn't matter which one we find first. I'm going to choose to find angle A first. So if I label this, this is my hypotenuse, this is the opposite side, and this is the adjacent side. I'm going to use the two side lengths that I was given, which are the adjacent and hypotenuse sides. So that means I'm going to use cosine. So I know that cosine of angle A equals adjacent, which is 8, over hypotenuse, which is 14. To solve this, you need to use inverse cosine. So if I do the inverse cosine of both sides, then I end up with measure of angle A equals inverse cosine of 8 over 14. So then I put that in the calculator. Inverse cosine is second cosine. And if I round to 3 decimal places, I get 55.15 degrees. Then I need to find the measure of angle B. So I could relabel my triangle with opposite, adjacent, and hypotenuse, or I could just do measure of angle B equals 90 degrees minus 55.15 degrees. So measure of angle B is 34.85 degrees. Those are the two different scenarios you could have for solving a triangle or solving a right triangle. You could either be given an angle and a side, or you could be given two sides. Let's review a couple of vocabulary words. Angle of elevation is the angle looking upward from the horizontal. So, if I am a person standing here, the angle of elevation would be this angle that I'm going to use the Greek letter alpha for. You're looking straight ahead, which would be at horizontal, and then you go up a certain number of degrees. Similarly, The angle of depression is the angle looking downward from the horizontal. And I'm going to use the Greek letter beta to represent this angle. If I'm standing up here and I look straight ahead at the horizontal and then look down a certain number of degrees, that angle will be beta. Let's look at a couple of word problems. There's a fire truck approaching an 84-foot tall building. The optimum angle of elevation for the ladder is 60 degrees. If the ladder is mounted 8 feet off the ground, how far from the building should the base of the ladder be? So let's label all of the things that we're told. We know that this building is 84 feet. We know that the optimum angle of elevation is 60 degrees. And we know that the ladder is 8 feet off the ground. We want to find this distance. Now, we know that this is a right angle, so we have a right triangle here. Because the ladder is 8 feet off the ground, we have that this side of the triangle is 84 minus 8 feet, which is 76 feet. So let's label our triangle from the point of view of this 60-degree angle. This is our opposite side, this is our adjacent side, and this is our hypotenuse. So we know an angle, we know the opposite side, we want to find the adjacent side. So opposite and adjacent would be tangent of 60 degrees equals opposite over adjacent. Now if we solve for A, we get that A is 76 divided by tangent of 60 degrees. So let's put that in the calculator. We get 43.879 feet. So the base of the ladder should be that far away from the building. In part B, we want to know how far should the ladder be extended to reach the roof. So we are trying to find the length of the ladder, which is B. Again, I'm going to use what I was given in the problem to avoid round-off error. So I know the opposite side, I want to find the hypotenuse. So that will be sine of 60 degrees equals opposite over hypotenuse. If I solve for B, I get 76 over sine of 60. And then if I put that in the calculator, I get 87.757 feet. So that's about how long the ladder would have to be to reach the roof in this situation. Let's look at one more problem. A flagpole is atop a tall building. From a point on the ground, 138 feet away, the angle of elevation to the top of the flagpole is 54.1 degrees, and the angle of elevation to the bottom of the flagpole is 47.5 degrees. How tall is the flagpole? So, I know that this is a right angle, and I know that from this person here to the base of the building is 138 feet. Then I'm given two pieces of information. I know that this angle is 54.1 degrees, and I know that this angle is 47.5 degrees. So essentially I have two triangles here. So let me break them out. This is 54.1 degree, and then I need to find the first height. Then I have a second triangle where the angle is 47.5 degrees, and I need to find the second height. In both of these problems, this is the opposite side, and this is the adjacent side. Ultimately, I'm trying to find the height of the flagpole, which we'll call x, and x will be height 1 minus height 2. Since I'm trying to find the opposite and I know the adjacent, I'm going to use tangent. So I have tangent of 54.1 degrees equals h1 over 138. So if I solve this, I have that 138 tangent of 54.1 degrees will give me h1. So if I plug that in the calculator, I get 190.640 feet. And then I'm going to do the same thing with the second triangle. I still have tangent equals opposite over adjacent. If I multiply both sides by 138, and then I plug that in the calculator, I get that height 2 is 150.601 feet. So x is going to be h1 minus h2. So if I do 190.64 minus 150.601, I get that the flagpole is 40.039 feet tall. This should be a review of geometry. In future classes, we're going to talk about how to solve triangles that are not right triangles.